Good morning. We continue with nitrobenzene. Next is harmful effects of nitrobenzene. Harmful effects of nitrobenzene. What are the how it will affect human being, or how will affect the animals, the presence of nitrobenzene. First one, the nitrobenzene may cause irritation to our skin. So one is causes irritation to the skin, and second one, it may cause what is this one? Methemoglobinemia. That means affect the oxygen transfer of blood. It may affect the oxygen transfer of blood. That particular condition is known as methemoglobinemia. Methemoglobinemia means it will affect the oxygen transport of oxygen transport of blood. Third one, it may cause jaundice or coma, etc. And it may decrease the fertility. These are the harmful effects of nitrobenzene. First one is cause irritation to our skin. Second one, cause methemoglobinemia, means it will affect the oxygen transport by blood. And third one, it may cause jaundice, coma, etc. And it may cause the decrease the fertility of human being. Okay, so these are the harmful effects of nitrobenzene. Next, we are passing to explosives. What are explosives? So explosives are solid or liquid substance, or it could be a mixture, which can be detonated into highly exothermic and a highly rapid chemical reaction, which will produce a large gas pressure in the molecule, finally will result in an explosion. This is what is called explosives. So what do you mean by explosives? So explosives are solid or a liquid substance, or it could be a mixture of solid and liquid. Can be detonated into highly exothermic and rapid chemical reaction will produce large gas pressure and will result in explosion. So this is what is called explosives. So explosives are solid or liquid substance, or it could be a mixture of solid and liquid, and it can be detonated into, it can cause explosion, it can be detonated into highly exothermic and very rapid chemical reaction, which will produce this highly exothermic and rapid chemical reaction will produce large amount of pressure in the molecule, and which will result in the explosion. These types of substances are known as explosives. So solid or liquid substance, or it could be a mixture, that can be detonated into highly exothermic and rapid chemical reaction, which will produce large gas pressure and will result in explosion. So let us go to some examples of explosives. Examples of explosive. First one is nitroglycerin. Examples. Okay, one is nitroglycerin. Nitroglycerin. Okay, what do you mean by nitroglycerin? You can write it as CH2ONO2. Okay, then CHONO2 and CH2ONO2. Actually, nitroglycerin is obtained by the nitration of glycerol. What is glycerol? CH2OH, CHOH and CH2OH. This is glycerol. This on nitration will give what will come here? CH2ONO2, ONO2. This is known as nitroglycerin. This is an example for an explosive, but this explosive will immediately detonate. Therefore, it is very difficult to handle. Okay, this is unsafe to use which one nitroglycerin, because this will immediately it can be detonated. So very difficult to handle. Okay, so unsafe to use. Now, Alfred Nobel developed a pasty stick-like explosive which do not immediately detonate, which is known as dynamite. Okay, another example is dynamite. But the problem with nitroglycerin is which will immediately will be detonated, so unsafe to handle. So Alfred Nobel developed a stick-like explosive which do not immediately detonated, which is known as dynamite. And second example is dynamite. Okay, and third one is you might have studied that trinitroglycerin, TNT. Okay, sorry, trinitrotoluene, TNT. So what is TNT? You know that. Okay, this is toluene. So NO2. Okay, this is 2,4,6 trinitrotoluene, 2,4,6 trinitrotoluene, which is known as TNT. This is another example for explosive. What is that? 2,4,6 trinitrotoluene. And next one is RDX. Okay, next one is RDX. Okay, look at it here. RDX. So RDX is research department. Explosive. Okay, that which is known as RDX. Its structure is like this. Look at it here. How the structure of RDX. Okay, and here it is N, and here also nitrogen. Okay, here it is NO2. Here is also NO2, and here is NO2. Okay. So this is what is called RDX. What is the actual name of chemical name of UPC name of RDX? You can see that 135 trinitro. There are three nitro group. 135 trinitro. Again 135 cyclohexane, which is known as RDX. 135 trinitro. Again 135. There are two nitrogen atom, which is known as 135 triazacyclohexane. This is cyclohexane, triazacyclohexane, which is known as RDX. So these are the few examples of explosive. One is nitroglycerin, second one is dynamite, third one is TNT, trinitrotoluene, and the next one is RDX, and which is known as 135 trinitro, 135 triazacyclohexane. Okay, these are some examples of explosives. Now, next is chemistry behind the functioning of explosives containing multiple nitro group. Okay, so you can see that in TNT, trinitro-toluene, and even in RDX, there are multiple NO2 groups are present. Okay, in most of the explosive, multiple NO2 groups are present. Now, what is the chemistry behind the functioning of explosives which containing multiple NO2 group? When there are NO2 group, what is the advantage of that explosive? So, chemistry behind the functioning of explosives containing multiple NO2 groups. Okay, multiple NO2 groups. Example is TNT, RDX, etc. They contain multiple NO2 group. So, what is the chemistry behind this one? First one is the NO2 groups are tightly packed in a small organic molecule. Okay, it is clear because even in TNT or RDX you can see that the NO2 groups are tightly packed in a small organic molecule. Second one, because of this tight packing of NO2 group, there is great strain in the molecule. Great strain in the molecule. Okay. Now third factor, the presence of oxygen. The presence of oxygen in the strained molecule, will help in oxidation. The presence of oxygen in the strained molecule will help in oxidation. That means what is that? That means I can write it here. Okay, that means the NO2 group will act as oxidizer. NO2 group will act as oxidizer because it containing oxygen, so it can release oxygen. That means NO2 group will act as oxidizer. Then the hydrocarbon part will act as fuel. So you can see that the NO2 groups are tightly. So chemistry behind the functioning of explosives containing multiple NO2 groups. First one is the NO2 groups are tightly packed in a small organic molecule. Correct. If you take TNT, you can see that NO2 groups are tightly packed in a toluene molecule. And second one, therefore there will be great strain in the molecule. Third one, the presence of oxygen in the strained molecule will help in oxidation. NO2 group containing oxygen. So what is that? The NO2 group will act as the oxidizer. It can produce oxygen and the hydrocarbon. Okay, if you take TNT, you can see that NO2 group will produce oxygen. Then the rest is hydrocarbon part. Of course, hydrocarbons are fuels, will act as fuel. And next reason, you can see that fifth one, this explosion can be initiated by a small friction, initiated by friction. If there is a friction in the molecule, friction, heat, flame, UV or other electrical discharge. Okay. With this any type of this friction, heat, flame or UV or other type of electrical discharge, immediately we can initiate this explosive. Okay. These are the reason. This is the chemistry behind the functioning of explosives containing NO2 group. Okay. That means this is very important. So first one is NO2 groups are tightly packed in a small organic molecule. Second one, therefore there will be a strain in the molecule. And third one, the NO2 group will act as oxidizer, and the rest of the part, that means the rest is hydrocarbon. Hydrocarbon will act as fuel, and you can see that this type of explosion can be initiated by friction, heat, flame, etc. Okay, and that's all about this one. Next is ANFO. What is that? Next is ANFO. What do you mean by ANFO? Ammonium nitrate fuel oil. ANFO, what is that? Ammonium nitrate. Ammonium nitrate. Ammonium nitrate fuel oil. Fuel oil. Okay, this is ammonium nitrate, ANFO, fuel oil, ammonium nitrate, fuel oil. This ANFO is act as a blasting agent. It can act as a blasting agent. That means you can see that ammonium nitrate is containing ammonium nitrate fuel oil is containing ammonium nitrate as oxidizer, which can produce oxygen, and the fuel oil, that fuel oil means, what do you mean by fuel oil? Long chain alkane, which can act as a fuel, and finally what will happen? The ammonium nitrate will produce oxygen, so it will act as an oxidizer, then which will ignite the fuel oil, and finally will result in the formation of a large amount of nitrogen, carbon dioxide, steam, etc. That means which will result in an explosion. So this is a blasting agent, means in the presence of another explosive like dynamite. Dynamite, what we can use this also. So this is a blasting agent. In the when we use dynamite, when dynamite is mixing with or dynamite is allowed to react in the presence of ANFO. So what is the advantage? The ANFO will in ANFO the ammonium nitrate will act as an oxidizer, which will produce oxygen. That oxygen will ignite the fuel. So what will finally will result in a large amount of very violent explosion, which will result in a very violent explosion. So keep it in mind, ammonium nitrate fuel oil, ANFO, is a blasting agent. Okay, blasting agent. Okay, when it mixes with when it mix with an explosive like dynamite. Okay, when it is mixed with, when it mixed with an explosive like dynamite, okay, what will happen? The ammonium nitrate will act as oxidizer. That means it will produce oxygen, and the fuel part. Fuel oil means, and the fuel oil, that is, what is that? Long chain alkane will act as fuel, and will produce large amount of carbon dioxide, nitrogen, steam, etc. Okay, will produce this much gases. So that means ultimately what is that? Production of large amount of gases means which will result in explosion. So it can act as a blasting agent. Ammonium ANFO can act as a blasting agent. Now what is the chemistry of ANFO? Okay, look at here. Suppose ANFO only if we are using, it can even ANFO can make explosion. How it can make explosion? Look at it here. ANFO, ammonium nitrate. The ammonium nitrate will decompose to form oxygen. So ANFO, ammonium nitrate, NH4, NO3. NH4, NO3 will decompose to give nitrogen, steam, H2O plus half O2. That means it can generate oxygen. This is the first step. Ammonium nitrate will decompose to generate oxygen. So here is our oxygen. Due to the presence of this oxygen, what will happen to our fuel oil? This oxygen will ignite the fuel oil. Okay. Now the combustion of fuel oil will produce large amount of carbon dioxide and steam. Okay, large amount of carbon dioxide, steam, and will release enormous amount of energy. Energy. Okay, that means ammonium nitrate will decompose and will produce oxygen. Due to the presence of this oxygen, what will happen to our fuel oil? This oxygen will ignite the fuel oil present in the ANFO, and because of this ignition, what will happen to the fuel oil? The fuel oil will undergo combustion, so it will burn and will produce large amount of energy with gases like carbon dioxide and steam. Okay, that means there is an explosion is taking place. Okay, now due to the availability of or low cost of ANFO, the ANFO is used in metal mining, okay, and or coal mining, quarrying to break the stones. What we are using, we can use ANFO. Okay, so it is used in metal mining. Then what is that? Coal mining and quarrying, etc. Okay, so keep it in mind. ANFO itself can act as an explosive, and at the same time it can be mixed with other explosives. So what is that? The explosion will be very, very dangerous, or okay, because this can act as a blasting agent for other explosives also. Which one? ANFO. Okay, so that's all about explosives. Okay, so keeping in mind explosive, some examples of explosive: nitroglycerin, TNT, RDX, dynamite, etc. Now what is the chemistry behind the presence of a multiple nitro group in explosives? So the nitro groups are closely packed and there is a strain in the molecule. The NO2 group can produce oxygen. The rest of the molecule, that means hydrocarbon part, will act as fuel, and what will happen by a small friction, heat, etc. it can explode. Then last one is ANFO. Okay, and thank you. We will continue in the next class.